Hey everybody. I hope that you did well on the test. A lot of people did really good job. So now we're hitting our last chapter. The last bit of course material here is all of chapter 9. And then we'll start wrapping things up. I can't believe the semester's almost over. It's been a strange semester. So we're going to do chapter 9. Chapter 9 is interesting, kind of to group all of chapter 9 together. It's a special study about functions, okay? So it's all about functions, and in particular, once we get deeper in, we'll study two special functions. Okay, that's what chapter 9 is about. These two special functions. We won't get to them for some time, but we're going to review a little bit of what we learned back in Math 105 about what a function is, and we'll go forward with some new ideas, and build upon that until we get to these two special functions. All right. So the first question right off the bat is remember what is a function? Who remembers what that is? And so here's the kind of textbook definition, which I want to tear apart to make it more easily understandable. It says a function, let me put this back, is a relation. So there's the first bit. Whenever we're talking about relations in math, those are things like equations, things where we are relating things with equal signs. So it's a relation, some sort of mathematical relation, in which each member of the domain, I want to talk about what that is, corresponds to exactly one member of the range. And I put this part in bold and underlined because that's the important part. Okay. So who remembers what a domain is? So all the members of the domain. Remember, the domain was just the x values. Or you could think of another way of thinking of it as the inputs. Okay, x values, inputs, things that you're plugging into the function. And the range, remember, those were the y values. Or maybe it's easier to think of them also as the outputs. Okay, so let's try to reread this now with a little better understanding. So what a function is it's just a special relationship between x values and y values. And what's the special relationship? Each x value has only one y value. Okay, no x values can be two-timing. Every x value has to be matched to only one y value. And so when I teach this, we go on a whole spiel about how society is. Remember my example about cheating men. So we'll call the x values the men. Just jokingly, they're the men. And the y values are the women. Whoops. If I could spell women. There we go. Are the women. And it's kind of like society. Because the women cheat, but no one says anything. They let them get away with it. But the men better not cheat. If you want to be a function, the men, no cheating men, okay? And actually, we'll talk about the cheating women a little bit next lesson. Okay? So let's look at some examples. So here's a relation. We can show relations as ordered pairs, as an equation, as all sort of stuff, as a graph. But we just want to see. So remember, ordered pairs are just x, y pairs, right? So this is an x, this is a y, this is an x, this is a y. And when they're in an ordered pair, those are the ones that are related. So you look to see if any of the x's are cheating. So this is Mr. 2 right here. He is with Mrs. 7. Do you see Mr. 2 hanging out with any other women? And you say, well, this looks like Mr. 2, but no, that's negative 2. Okay? So that's his evil twin, not the same person. So even though he's with a different woman, that's not the same Mr. 2. So Mr. 2 is not cheating. How about Mr. 1? Do you see Mr. 1 hanging out in any other pairs? No. So he's not cheating. Mr. Negative 2? Now we already said that negative 2 and 2 are not the same man. So he's not cheating, and Mr. 9 is not cheating. So yes, this is a function. There are no cheating men. Every x value only has one y value. And you may say, well, what about Mrs. 7? What about Mrs. 7? She's cheating. But the definition doesn't say each y value has to have one x value. It says each x value has to have one y value. There's a difference there. Okay? So what about cheating women? We really don't care when we're talking about functions. But I give you a tease. We will care later. We'll talk about that, okay? So with points, yes, we can easily check just to see that none of the x values are cheating. Very simple. With a graph, remember we had this thing called a vertical line test. And I'm going a lot faster than I would teach this if this were something you were seeing for the first time. But vertical line test, we say, oh, x values, the points on an x value, I can hit every point at one x value with a vertical line, right? And so we can look for cheating x's by drawing, let me get a different color here, go with purple, by drawing vertical lines. So at Mr. 2, how many women does Mr. 2 have? Just one. Is there anybody you can find, each vertical line represents an x value. Is there any vertical line, any x, that has more than one woman? And the answer is, I don't see any. So what does that mean? There are no cheating men, so that means yes. This one is a function. Over here, I can find lots of cheating men. Draw a vertical line. Can you find any cheaters, any x values? Look, this x value of 1, it has two different women, two different y values, two different outputs. Right here and right here. And I bet you can find a lot. Almost anywhere that you draw a vertical line, you're going to cross the graph more than once. So that means there's a lot of cheaters. So no, this is not a function. Not a function. Okay. Now I will say that the worksheet that I'm working off of, I typed it up the other day. It will be sent out in an email with this if you wanted to use it to take your notes on and maybe post it in Blackboard. Okay. Alright, so that's just review of stuff. So let's talk about a little bit of new stuff. Something called composition of functions. So now that we remember what functions are, we're going to talk about composition of functions. Well, what does it mean? Remember, the idea of a function is you could take anything and plug in for x. So I could stick any number I want in there, and it will show up right there. I could stick any equation in there. I could stick any function. I can stick anything I want in there. That's what composite functions is. It's like taking a function and plugging it into another function. It's like an onion. It has layers, or maybe, just something that takes a function and plugs another function in. So the way we write it, normally this is the way we write it that's less fancy. You see, this is the f function, and what's inside of the f function where the x usually goes? A whole nother entire function. Well, how do we write that? F of g. We use this little circle notation. That's the fancy way of writing it. Now, order's important. The one that's first, the f, is the function that's on the outside. The second one is the function that's being plugged in. Okay. Now, usually people teach this with doing a number first and then doing the generic x. I find it easier to plug in the x first and then try some numbers. Okay, so here's our two functions. Let's do some examples. So I got this function f and this function g. Okay, there they are, x plus 3 and x squared. So look at this one, f of g of x. F of g. So which one's the outside function? That's f. So I always write mine over, because I like this notation a lot better. But it's not considered as fancy or as formal. So a lot of textbooks and stuff in literature prefer it written this way. But I like it this way because I can see what function is on the inside. So here's how we're going to do this. What's the outside function? It's f. What are we plugging into it? Something. Ignore what it is for right now. How do I tell you to plug stuff in? Rewrite the function, but leave a big blank parentheses where the x is. Big blank parentheses plus 3. Well, what are we plugging in? We're plugging in g of x. I'm going to take the extra step to write g of x. And then you say, okay, that's nice and fine and dandy, but what is g of x? Oh, I know what it is. It is x squared. So I'm going to now replace g of x with what it is, what function it's representing. So let's see what I get here. I'm going to get equals something plus 3. What is that something? X squared. Now, once you finish plugging in, you do need to check for things that simplify. Do I have any like terms? The answer is no. Do I have anything I can distribute? No. So this one's pretty simple, just x squared plus 3. So we just did our first composition of functions. We stuck a function inside of another function, okay? We can obviously make these way more involved than this, just x squared and x plus 3, but for our first one, I wanted to make it a little bit simpler. So now, what I can do with this is I could say, oh, well, I could plug in numbers as well. So you could take the time of plugging a number into G and then plugging that answer into F, but why not just use what we've already done? We've come up with f of G, right? F of G. I know what this function is. This function is going to be x squared plus 3, or blank squared plus 3. But what am I plugging in here? What am I plugging into this function? A 5. Now before I evaluate this, everybody understands what I just did. I saved work by doing this one first, f of G of x. I know what this composition, this layering of functions will give me. So then if I want to plug in an x value, I can just steal this work and plug in that x value. And the rest of it's just arithmetic. What is 5 squared? 25. What's 25 plus 3? 28. Okay? All right, let's do another example. Help me remember what these are, because I'm going to scroll past and lose them. X plus 3 and x squared. What if we compose in the other direction, other order? We go g of f of x. So let's write this the non-fancy way. So tell me, what's the outside function here? G. So what was g? It was x squared. Do I know what x is? No, I'm plugging something in for x. What am I plugging in for x? F of x, an entire function. Okay. Now, what happened to be, what is that function? It happens to be just x plus 3, right? So I'll replace the notation with the actual function. And now I can simplify this. Now be very careful simplifying this. This is one of those that will make math teachers pull their hair out. This is x plus 3 squared. Remember, x plus 3 squared is x plus 3. What does it mean to square something? To multiply it by itself. X plus 3 times x plus 3. Which means that you will have to FOIL it in combined like terms. I'll be your magical calculator and go quickly on this one. But you can take the time to FOIL that out if you don't remember how to FOIL things or you need to practice, okay? So x squared plus 6x plus 9. Awesome. So could I plug a number into that one? Yeah. I've already done g of f of x. This is what you get. What am I going to plug in? A 4. So I can literally just steal my work from my last problem. I'm okay if you do this on any of your work or on our test. And say, okay, well, what am I plugging in? And what are we plugging in is a 4. And I strongly, strongly, strongly suggest you do it the way I'm showing and do it the way I've been fussing at some of y'all for over 2 semesters now, or over a semester and a half, that if I'm going to plug anything in, I prefer you to write it blank first. Anywhere there's an x, leave blank set of parentheses and copy everything else down outside exactly. Then plug in whatever you're plugging in. So now it's just some arithmetic here. You could use a calculator, or you could do it for fun to keep your brain sharp during this nice lockdown we're on. 4 squared is what? 16? 6 times 4 is 24 plus 9. And now we just need to add these up. Let's see. Well, 16 plus 24, that would be 40, isn't it? Bring down that plus 9. And 40 plus 9 is 49. Awesome. All right. So maybe one more batch of examples. A little bit harder functions this time. We'll do the same thing. We'll compose this f of x and g of x. So let's go f of g. So remember, order is important. So I'm going to take the time to write it out this way so I can see what's the outside function and what's the inside function. So the outside function is f. So what is the function f? Square root of blank minus 2. Square root of blank minus 2. My blank may not be quite big enough. Let me make it a little bit bigger this time. There. Awesome. Now what are we sticking in there? What's plugging into the function f? An entire function, g of x. Okay, so can I rewrite this? And instead of g of x, can I put the function that it's actually representing in there? Yeah. So what is g of x? 5x minus 2. Alright, now let's see if this simplifies any. And it will, because minus 2 and minus 2 are like terms inside this. They're both inside the radical, so I can get minus 4. Now these are not like terms. I cannot square root this whole polynomial. So there we go. That's all we can do. Square root of 5x minus 4. Alright, awesome. That should make the next example when I'm doing f of g again, f of g, and instead of an x, I'm going to just plug in an 8. So it's exactly the same, but I'm plugging in an 8. So equals the square root of 5 blank minus 4. And what are we plugging in? An 8. Well, what's 5 times 8? That is 40. Don't forget the minus 4. 40 minus 4. That's 36. Somebody was really nice. 36. So what's the square root of 36? That is 6. Somebody was really nice and gave you a pretty problem. That came out to a pretty answer. Okay, it was me. I'll admit. Alright, so let's see if we can do the other way, because that's my next example. Is going g of f. Alright, help me remember the functions. 5x minus 2 and square root of x minus 2. So this is g of f of x. So the outside function is g this time. And let's see. And g was 5x. So 5 blank minus 2. I hope I remember that correctly. Let me scroll up and look. 5x minus 2, yes. 5x minus 2. And what are we plugging in? Plugging in the function f. Well, I can actually write that out. What is that function? Make sure we have plenty of room to write it out. That function is the square root of x minus 2. Alright, so we say, okay, well, that's nice. Can't we simplify this? Well, this 5's on the outside of the radical. I can't smush it back in. And this 2's outside and this 2's inside, so I can't combine them. So that's all we can do to simplify that one. Really nothing besides just putting it together. Sometimes that happens. It's no big deal. Less work for us. Okay, now can I do the same thing and plug in an 11? So what's my final answer? 5 square root of blank minus 2 outside the square root minus 2. And we are plugging in an 11. So let's see, what's 11 minus 2? That is 9. 5 square root of 9 minus 2. What's the square root of 9? That's 3. 5 times 3 minus 2. 5 times 3 is 15. 15 minus 2 is 13. Awesome. Okay. So next time we'll start looking at some other special things with functions. Okay. We'll keep building on all this function stuff. That's all I have for you. Make sure you try the worksheet. The answer key is going to be posted with it as the second page. All right. I'll talk to you guys later.